Workplaces, factories, buildings. They all require maintenance. So occasionally an employee comes by and does some inspection. But this employee can sense everything. A gas leak, for example, can go unnoticed for years. A possible solution for this is to place a lot of sensors to monitor everything, though this costs a lot of money. The companies here, MWLC and Sorama, asked us to develop a robot which can drive autonomously around this area and detects any problems using a sound camera. These companies helped us by providing us with some of their hardware. HTES Technologies provided us with an attachable tracker for the robot and access to their tooling, which, among other features, allowed us to mark different areas for the robot to stop in. MWLC provided us with a robot that can drive autonomously around a predefined area. And last, Sorama provided us with a sound camera which can be used to detect any of the anomalies. These components were made by different companies and initially could not communicate with each other. To solve this issue, we implemented a middle layer. This layer connects the different hardware components to a centralized system. Since the components can now communicate with each other, the next step was to define how they communicated with each other. We decided to use a publish/subscribe architecture, as this allows the system to be abstract and expandable since every component lives on their own using the data they receive. In the first prototype, we let the robot drive an autopilot. We sent the messages manually to see if the communication worked. In the video, you can see we're going to make two short stops. In the first stop, the camera measures the area and hears nothing special. And during the second stop, we start clapping our hands near the camera. This will trigger an error. In the message log, you can see that the first report of the camera, the defect property is false. In the second camera report, the defect property is true, which is a great success. In the second prototype, we let the robot drive by itself. We marked several geofences using the tooling provided by HTES Technologies. Once the robot arrives in any of these areas, the robot auto-stop and measure whether there's a defect around or not. Once the robot is done measuring, it will publish a report and continue to drive to the next area. All measurements will be displayed on the dashboard. If any of the measurements indicate that a defect has been detected, an email will be sent to the right authorities. Our project was the initial project, and there's still a lot of work to be done. The robot will have to use a mobile network to ensure it can drive anywhere. Also, the robot will need an extra batteries to power the added hardware components. And last, the dashboard has to be improved for better experience. We believe the fundamentals are there, and this project will grow in something amazing. This project was only made possible by the help of HTES Technologies, MWLC and Sorama. We thank them for the help and guidance.